Okay, so we've done boilerplate constructor and toString equals, which was not quite as simple as it seemed. And then, of course, we've been told that as object-oriented programmers, when you override equals, you must override hash code. Yeah, down there, little bokoblin. Why? Why do we need to override hash code? A bunch of standard libraries rely on the fact that if two things have different hash codes, they can't be equal. Okay, so if you, or put it the other way, the contrapositive, uh, if two things are considered dot equals, they must have the same hash code. Okay, and there's code that relies on this in standard libraries. If you put things into a Java util hash table, it's going to, if it ever takes two objects and hashes each of them that gets a different hash code result, it's going to assume they're different, even if they had all the same fields. Okay, and again, so in Java, the default hash code goes ahead and uses as an object's hash code, it uses basically its memory address, which is fine if your concept of identity is identically equal, the exact same reference, the exact same memory location. If you've changed your idea of equality to mean corresponding fields, we'd better make sure hash code reflects that as well. So let's go ahead and do that. For some test cases, of course. In fact, our test cases might be similar to this equals. I'm going to copy and paste those three. b1.hashCode equals, well, b1.hashCode equal to b1.hashCode. Hashcode returns a primitive int. This seems kind of silly, but I guess it at least captures the fact that the hash code doesn't change from one call to another. I'll keep it in there just because I had it before for equals, had the corresponding test. Okay, b1.hashCode equal. Yeah, if we take this new book object, and I'll just leave it as new book, one that had all the same fields, but hey, this hash code better be the same. And then B1 and B0 have different hash codes. Now, one interesting property of hash codes is they don't necessarily need to be different. The constant function 17 is a valid hash code, a valid hash function. After all, it meets the criterion that if two objects are equal, they'll both have the same hash code. Well, if everybody has the same hash code, that's still true. But anyway, but it'd be nice if different objects, if they differed in any field at all, it'd be nice if most likely they were different. I'm not going to talk about hash functions and collisions in general. And keep in mind, we're not talking about cryptographic hash functions. So we're not worried about people being able to reverse engineer or construct, given one object, can you make another object that has the same hash code? If you can do that, that's okay for us. We just don't want them to arise naturally in practice very often to get good efficiency. So that's what we're going to be after. Okay, so I'm going to go ahead and hope that I'll leave it as not the case that they are equal. Okay, so those are our tests. I guess if I should relay this in the back of my head, if by dumb luck B0 and B1, whatever hash code algorithm I come up with, and by dumb luck B0 and B1 happen to collide, then that could be correct code, and yet this test case would fail, so maybe it's not a great test case. But I'll stick with that. I expect them to not have collisions just by accident. Okay, so let's go ahead and override hash code. Public int hash code, and we're going to go ahead and say we're working with a book, and we know that we have from the recipe anything dealing with the book is going to have those four fields: this dot title, this dot author, this dot pages. Okay. Okay, let's go ahead, and our job is to return an int. You know, actually, just to make sure I have everything stubbed out, I'm going to say return 17. And let me comment out the rest of it for now. Just to make sure I have everything in there and I can still compile it. In particular, I'm wondering, have I spelled hashcode okay? Is it a capital C? I can never remember. In fact, I have an error, so good thing I did this. Method does not override or implement a method. Okay, so, gosh, is it this? Yeah, I don't have that error anymore. Okay, so now I have other errors because I misspelled it down here. So sorry for not getting that first. I make this mistake all the time. Okay. So really, you know, I should have gone ahead and checked that when I write that very first test case. I should have compiled. Oh, go away, other screen. I have no idea what happened there. I'm trying to fix that letter C. Computers, they baffle me. Okay. Yeah, after writing that very first test case, it should have compiled and I should have tested that. But as it is, I had to change a bunch of stuff for all the same reason. No suitable method for hashcode book from object is not applicable. Oh, yeah, I can't pass a book to hashcode. I meant to change this to, this is equal to, B1 hashcode is equal to B1 hashcode. Okay. Now I go ahead and compile. Great. Great, so return 17 would work. Could actually run and pass all the tests. It would actually pass the first few tests, but it wouldn't pass the last test because B0 and B1 would have the same hash code. So it's not a very good hash function. Okay, what's the idea between a hash code for a hash code? Come up with some int that is probably going to be different than the int you get from other books, from other combinations of these four fields. By the way, the template suggested, hey, this is a string. What method could we call in strings that might help us in this code? Oh, hey, look up the strings hash code. Okay, so that's an int. That's an int. NumPages is already an int. You know, you can go ahead and I could convert it to a capital I integer and then call its hashcode method. Ints return themselves as their hashcode, so it's, I haven't suspect that'd be redundant. Booleans can go ahead and return that. So, you know, maybe I should do this just to sort of show how I'm being more methodical about this, and it's really boilerplate. For the wrapper types, first I curse Java, curse you, Java. And then I say, okay, I'll go ahead and cast this to a Boolean, capital B Boolean, and then call its hash code. And, you know, even though I don't need to, I could go ahead and do this and then call its .hash code. Okay, now I have four different ints. Let me just combine these ints into a hash code. One thing I could do is I could just add them up. Remember, ints wrap around a positive 2 billion, they wrap around to negative 2 billion. So I can just add them up and I'll get another int, everything's fine. The one drawback is if somehow I had two different books that had their author and title switched, then, gosh, those two things would collide, even though I don't want them to. Okay, anyway, so here's what we do in real life. We're going to go ahead and we're going to have a running int here, h for hash, and initialize it to 0. And at the very end, I'm going to return h. Okay, and here's what I'm going to do. I'm going to go at every step. I'm going to say, I'm going to be building up this h, get bigger and bigger and bigger. I'm going to, at every step, we're going to shuffle the bits and then add in the next field. Okay, so how do I shuffle the bits? I'm going to multiply it by some constant, a constant that happens to shuffle bits. People like to use a power of 2 minus 1, so like 31 or 63. Okay, do that, and then go ahead and here. And now I'm going to go ahead again, boilerplate. I'm going to repeat these lines. So first let me do here, here. Oops. need to do it down there. H plus gets, H plus gets, H plus gets. Okay, so shuffle, add in the titles hash code. Shuffle, add in the author's hash code. Shuffle, add in the number of pages hash code. Shuffle, add in the is copyrighted hash code. You can probably figure out, I know that H started as 0, and when I multiply it by 31 or something like that, I'm still going to get 0. So I could get rid of this step here, but I don't really have a strong opinion on that. I kind of like it being there to show the consistency, but by the way, I should go ahead and make this a private static final int shuffle bits. 31. If I were in Java 9, I believe, Java 8, Java 9, I could go ahead and actually put a binary literal in Java. Unfortunately, this IDE came with this old built-in Java, and it's an old version of Java, so I don't think I can do that. Let me try it. Oh, well, no, it actually didn't complain there. Maybe this one, maybe the IDE has been updated. It's Java. You're expected to forget your semicolons. Semicolon expected. Oh, I see it. No, this doesn't work. So, yeah, I'll go ahead and make it 31. Maybe I just have the wrong syntax for binary literals in Java. Anyway, we're good. Now I can compile this. Let's go see if it passes the test cases. Yep, no assertions got triggered. Okay, so everything passed. I'm going to add one little bit. So we're done now. We're great. We can move on. One little thing. I'm going to go, and for efficiency, hash code could get called pretty often. That's a pretty standard function. You're adding and removing from data built-in collections. It can get called a lot. This is not horribly complicated code, but we can do a little bit better. We can go ahead and compute the hash code once and then cache it. Okay, so here's what we're going to go ahead and do, and I'm going to be a little bit sloppy here. I maybe should be using an option. I want to say, hey, I'm going to go ahead and have the cached int cached hash. Okay. And there's a couple of different ways to do it. One would be to set it to 0, and then if cached hash not equal to, if it's equal to 0, go ahead and do this. Now this is actually kind of nice because this goes ahead and ensures that we're not even going to call this code once if nobody ever actually checks for the hash code. Okay, and I'm not going to, let me change things here. I'm going to end with cached. Oh, and I misspelled cached. Oh my goodness, what's going on? Cached hash gets H. Return cached hash. Okay, this needs to be a static. Not final. If I set it to 0, then I reassign it, but it's definitely, oh, I'm sorry, not static. Every different object has their own cached hash. Will be private. We'll set it to be 0. Okay, so this is good. The one little glitch that occurs to me is, what if naturally the hash code ends up being 0? The actual computed hash code when we go and run all this. Well, then we're going to keep recomputing it. Now that doesn't happen very often, so maybe this is just fine. And in fact, in the Java library, you can look at the Java string, in class string, you can look at their code for how they run hash code for strings, and they do exactly this. And if a string happens to compute 0, they run the whole algorithm and loop over all the characters to recompute the hash code if it happens to be 0. It happens so little, that's not a valid or not a major concern. If you really want to do it more right, I should really use, I want cache hash to either be an int or to be, hey, I haven't been computed yet. That sounds like a union type or an option type. I can maybe use the option or maybe classes, or I can be old school, lowbrow, I can go ahead and use a capital I integer, cached hash gets, use null as my sentinel value, and then do this, and then return cached hash here, and it will, I don't need to say return int value. The type system knows that if I'm returning a small int, it will go ahead and do that. I like this because it feels more right, even if it's a little bit slower than that zero trick we used. Okay, and now let's go ahead and compile that. By the way, here's where that static will, if I accidentally made the static, then every different hash object would end up returning that same cached value, and my test case would fail. So that last test case. Okay, but as it is, I think we're going to be good. Woohoo! And that is the boilerplate code for constructor and toString and equals, and yeah, if you override equals, you better override hash code. Okay, makes you wish a language would just do this for you. A lot of languages do, Java don't. Enjoy.